Welcome to the sixth event of the CLIMAAX Community of Practice. I'm Anna Pirani. I'm a senior scientist at the Euro-Mediterranean Center on Climate Change. So one of the partners developing the resources and the tools that we hope will be really useful to underpin your work in climate risk assessment. So in this session, we're going to discuss some of the issues around using and selecting and how to understand future climate change scenarios. And we know these are crucial for our work, looking into the future of how the hazards that are driving risk in our regions are changing with a changing climate. So we're going to talk about how climate scenarios are generated and what bias and uncertainty mean in the context of scenarios. And so what kind of choices are available for you to decide which information is most suitable for your application. So you know this is part of the framework of CLIMAAX, and it's one of the core technical choices that we have for assessing climate risk. And we have some colleagues who will present a toolbox workflow that is under development to help you practitioners to intuitively visualize climate scenarios and look at the regional biases and uncertainties and find which option is most suitable for your work. So, you know, in the community of practice, this is a modality to work together. So the idea is really to exchange. We present work which is in progress. So you'll see some initial results or some initial proposed characteristics of the workflow. And the idea is really to discuss together if this is suitable, if this is understandable, if you find this is going to be useful for your work. And this feeds back into the way the project develops the resources. So the next slide, I just have a couple of housekeeping rules. Okay, so we re-record the meeting for our purpose afterwards so that we keep track of all the questions and the issues that come up. We ask you to keep your microphone switched off, but then you're very welcome to raise your hand and ask questions. We have a very informal setting here, so we're working together. So feel free to raise your hand, or you can also write in the chat if you have some clarification questions, and we can mix between answering in the chat, but much nicer if we can actually discuss. And at the end, we'll also have a mentee to pick up some more insights from you to help us in this work of the community of practice. So the next slide is just to give a bit of a taster, a scene setting. These are findings from the last IPCC reports. And I think this figure is a very iconic figure that shows really well how up until now we've seen warming climates. If we look up to 2020, but if we look into the future, we have a range of possible outcomes, and they really depend directly on the choices and practices that relate to greenhouse gas emissions and also the use of land. And so we have scenarios where we may have very low emissions that lead to a degree of warming by the end of the century. And then successively, as the level of emissions increases, you see how the temperatures globally could increase by the end of the century. And if you click one more time, Fulvio, if you click once more, that's it. Thank you. This figure is really hitting it home how we have to understand what are the consequences of these different futures for people. And this figure shows you how essentially children born today, we can expect that they will experience more extreme events, which are more frequent, more intense in the future. And by how much depends on these future emission scenarios. We can start to understand what the consequences might be and how we might prepare. And then the next slide is to show you how extremes become more severe and frequent as global warming increases. And this first image shows you a 1 in 10 year event of a hot extreme, say without human-caused climate change. It occurred once in this case in every 10 years. And then if you click once for me, Fulvio, you see currently we already see a perturbation. So it's already happening more often. It's more likely to happen now with the current conditions. And then if we look further into the future with increasing warming, you see how this frequency increases. And we have to understand these changes to help prepare. And if you click once more, we have information that all types of extreme events will change with increasing temperatures. And then one more slide, just to finish scene setting. You know the determinants of risk are get quite complex as it is to understand the interplay between the climatic and non-climatic drivers of risk. And we have one click, and it's just to really illustrate how the climatic drivers are changing in characteristic. So they may become larger in magnitude, the increase in frequency, but they may also occur in new locations with different timings, and there could be different combinations or even compounding effects. So the idea in this workflow and in assessing risks in a changing climate is to try and understand these evolutions in the future. So with that, let's move to the agenda. And we'll have a presentation by Jeremy Powell to understand climate scenarios a little bit more, what we talk about. And then we move to a presentation which will be shared by Majid Nyatskar and Andrea Rivosecchi, and they will start presenting you this new workflow. And at that point, we can really start discussing whether it's suitable, whether you're finding this work is going in the right direction, and we'll have an interactive discussion to hear your views and help us refine this workflow. So let's go to Jeremy's presentation. And Jeremy is a senior researcher at the Euro-Mediterranean Center on Climate Change. He's part of the Risk Assessment and Adaptation Strategies Division, and he has over 25 years of experience in the field of climate change, and he's been working on the impacts on water resources, the hydrological cycle, extreme events, and different sectors, including agriculture, human health, and the natural environment. And he's been working a long time in the assessment of risk and the different drivers of risk, of hazards, exposure, and vulnerability. So let's move straight to Jeremy's presentation. I give you the floor.
Hello, everyone. Can you see my presentation in full screen mode?
Yes, it works.
Okay. Thank you, Anna. Thank you for the nice introduction. And I'm not just going to talk about uncertainties. I decided to add something on climate models as well, just give you some basics of sort of a 101 overview of climate modeling and then the uncertainties associated with the modeling, but also the uncertainties associated with the scenarios. I think we all know that our greenhouse gases have been increasing. Let me just put the pointer on here. Okay, I won't put the point on. And at the same time, at the same time, our temperatures have been increasing. And I think many of you in the room are doing risk assessments, and you can do risk assessments of using past data sort of as a representation of the current climate and the changes that we've been seeing so far. But to perform a risk assessment of climate in the future, we need to have some indication of what climate will do in the future. And the only way we can do that, or the best way to do that, is using global climate models, or GCMs, and some people call them Earth system models or general circulation models, but typically they're global climate models. Global climate models are 3D representations of the major components of the Earth system. That includes the land surface, the atmosphere, the oceans, the ice, and so on. Essentially, what a model does, or the way they're configured, is that the Earth's surface and the atmosphere, as well as the ocean, are divided up into a series of grid boxes. Okay, and then these, and you can see them depicted in this picture here. And in each of these little boxes, the key processes are represented numerically. And we use them to simulate a variety of processes. And some of them are related to climate change and land cover change, but also many other different things one can use them for. They're very, very computationally intensive. They typically run on our very fast supercomputers, and they can even take months of simulation time on these supercomputers. The resolution of these GCMs, at least for the IPCC and the CMIP6 project, which I'll talk about in a minute, is typically on the order of about 100 to 200 kilometers. Now, for those of you doing risk assessments for, at the local level, this resolution may even just cover your whole entire region, and you only have one little grid box representing the climate in the whole region. So we'll talk about how to downscale these projections to get to enhance the information. But we need to talk about the Coupled Model Intercomparison Project, otherwise known as CMIP. Okay, it's a collaborative initiative used to improve the understanding of climate change. It's organized by the WCRP, or the World Climate Research Program, and the initiative started in 1995. And it really serves as the basis for the IPCC climate projections. The most recent phase is CMIP6, and they're working on CMIP7 now. There are over 50 modeling centers. So that means we have climate models basically they're depicted in these maps here, but climate model simulations coming out of each of these locations here that are being provided for IPCC assessments and other assessments. And again, the resolution, which is really is important, is that the resolution is quite coarse to a certain extent, and it's at about 100 to 200 kilometers. This image here shows these simulations. This is global mean surface temperature. Okay, the black line there is the observations. Okay, so from 1850 to 2020, I believe, and what we can see here with the colored lines, each colored line represents a different model. Okay, and if you take the average of these models, you get the red line here. And a few take-home points here is one is that if you take the model, the average of the ensembles, the average of each model, which is called the ensemble mean, you get the best representation of the historical climate. But also what's important here is that you can't reproduce the observed changes in increasing temperature without changing the greenhouse gas concentrations in the model. And another important point, and that a lot of people aren't aware of this, but model years are not really tied to real world calendar years. So they could really be representative of any year in a sort of a time frame of 10 or 20 years. So you wouldn't expect any of these individual model lines to perfectly match the observations, but you would if you took the average of several years, they should match the observations. Okay. It's also really important to emphasize that all models are wrong, but some are useful. That's an expression or a saying by George Box, who was a famous statistician. So there are uncertainties coming out of these models, and we need to understand how to deal with these uncertainties. And again, this is very important. The best representation of the observations tends to be the ensemble average or the median of the ensembles, which you can kind of see in this picture here with the red line and the black line. Just to give you a little bit of idea of how these models spatially represent precipitation, on the left we have the observations from the GPCP, and on the right as CMIP5 ensembles, the previous generation of the CMIP models. And you can see in general, at least if you squint your eyes, they do a pretty good job of representing the observed distribution of precipitation. Yeah. Okay, but that's great. We can represent previous climate, but we have to we're trying to reproduce. We're trying to make some projections about future climate. We don't know what we're going to do in the future. So what has been done is by IPCC and CMIP, they come up with what are called representation concentration pathways. So these are different representations of the greenhouse gas concentrations in the atmosphere. Okay, these are RCPs. Some of you have seen, many of you have seen these before. They have 2.6, 6.0, 8.5, so on. And that number actually represents the radiative forcing at the end of the century in watts per meter squared. It's not really important to understand the physics there, but it's basically a representation of the energy imbalance associated with the greenhouse gases being present in the atmosphere. So it's the extra warming or the extra energy that the greenhouse gases provide. There's several different scenarios that are being considered. It's the low concentration scenarios, which are 1.9 and 2.6. They're maybe somewhat similar to the Paris Agreement of 1.5 or 2 degrees of warming. We have an intermediate emission scenario or a concentration scenario, which the RCP 4.5, and then the 7.0 and the 8.5 that are considered very high or higher, very high concentration scenarios. And there's some others in between if there's a 6.0 scenario as well. But they really serve as the basis for the IPCC projections. You can see here the evolution of these different atmospheric greenhouse gas concentrations here with carbon dioxide, methane, and nitrous oxide. I don't want to get into this here, but there's also something called global warming levels that we consider. So it's looking at the response to specific levels of warming. For example, you can see when the global temperatures reach 1.5 degrees or 2 degrees, and see how the climate of a particular region responds to that warming. And that's often another way to look at these climate change projections. Okay, so to form these RCP or these concentrations, atmospheric concentration, we have what are called shared socioeconomic pathways, or SSPs. Okay, and they're used to drive the emissions, and which then turn into the atmospheric greenhouse gas concentrations. And these socioeconomics that are considered, there's population by age, sex, education, economic development, land use, urbanization, energy supply and use, and so on. This is just a depiction of some of these here. Population, GDP, so the gross domestic product, and urbanization. And you can see here there's quite a bit of even uncertainty associated with these. For example, with population, there's more than twofold difference between population with a SSP1 versus population at SSP3, or not quite twofold, but and then same with GDP and urbanization. So what's really important to understand here is that it's not just the hazards that we should be considering, but we should also be considering the exposure components of risk and the vulnerability components, and those are represented in these SSPs. And here's just a depiction of the 5 different SSPs that are considered. From 1 from sustainable development, 2 is middle of the road development, SSP3 is regional rivalry, 4 is inequality, and then 5 is considered fossil fuel development scenarios. So how do these models project future climate? This is an image showing that. We have sort of, I guess, 5 different scenarios plus the observations, the historical simulations, along with the ensemble mean of that. More than 50 models here that the IPCC is using, and these 2 solid lines that I'm highlighting here is the SSP 5-8.5. So it's the SSP 8.5 coupled with the RCP 8.5, and it's the solid line is the multi-mean the ensemble of the models, or the mean of the ensemble, the models. And the blue line is the SSP 1-2.6, so SSP1 coupled with RCP 2.6. That shading really gives some measure of the uncertainty. Okay, and there's 2 uncertainties that are being considered here, but in this particular case, we're looking at the uncertainties with the models. Okay, so the shading, the difference here is the uncertainty, the differences between the different models. We have some models that are more sensitive and some models that are less sensitive. Okay, the projections in 2100 range from about 1.5 to 5.5 degrees globally, roughly double over land. And if we look at precipitation, we can see that the uncertainty is quite much larger, and that's because precipitation processes are much more complex to simulate, and there's some models that show greater increases in precipitation, and others that show smaller increases in precipitation. A couple key take-home points here is, one is that at the midterm, so if we say look at the 2050s, the climate depends more on the intermodal variability than the choice of the scenarios. So there's not quite as large of a difference. There's not a huge difference between the different scenarios, but there's still a large difference between the models. But as we move towards the end of the century, we can see that the scenarios begin to separate. So there's quite a big difference between SSP 585 versus SSP 126. And the intermodal variability is also quite important there. So those are important considerations when we're thinking about the timeframes. It may be more, if we're looking at just 2050, it may be just look at the entire suite of the SSPs. Doesn't so much matter about the ensembles, but it matters more to get a good representation of all the models there. Whereas at the end of the century, we want to start considering the different scenarios along with all the models. Okay, so talked about the typical resolution being about 100 to 200 kilometers with these global models. We have three sort of common approaches to enhance the resolution of the GCMs, and this is called downscaling. So how do we take the coarse resolution of the GCMs and refine it, enhance the resolution, in a sense, add more pixels to represent better represent the local climate. The first type is dynamical downscaling. So it's when you basically nest a regional climate model, or it's like taking a small version of a GCM, but at a high resolution, and just nesting it inside the GCM itself with a better representation of the topography, coastlines, and processes to enhance the climate. Another is a statistical approach. It's called statistical downscaling. You can use regressions, neural networks, and so on to transform the climate data to a higher resolution. And the third approach, which really isn't a unique approach, but it's sort of a combination of the two. It's a hybrid approach. Is take the GCM to the regional climate model and then do some statistical downscaling approaches. So we have in this picture here, we have a GCM at 100 to 200 kilometers. Regional climate model at somewhere around 10, 25 kilometers. And then maybe we're doing some bias adjustment to look at climate for the Nitra Basin in Slovakia, which I think Majid was going to show some results for. Okay, let's talk a little bit more about the dynamical downscaling. I think many risk assessments are using what's called the CORDEX product, or this coordinated simulations of high resolution regional climate models. It's also organized by WCRP, and you can see here in this picture all the different domains we have for this CORDEX experiment. We're using EuroCORDEX, so for the European domain, but there's also a Mediterranean domain, by the way. And these are simulations at 12.5 kilometers sub-daily. Okay, there are more than 130 combinations of GCMs, RCMs, and different RCPs. So there's quite a bit of data, like terabytes and terabytes and terabytes of data. One disadvantage of this current product is using CMIP5. I think CMIP6 should be out fairly soon, hopefully. The version that we suggest using, or we typically use, is this bias adjusted product. The daily product is actually adjusted using that hybrid approach that I mentioned. If you need sub-daily data, the data are not bias adjusted, but that can be done as well. There are many, many variables, and including snowpack, precipitation, temperature, winds, and so on. Yeah. There are some other data sets available that are downscaled, just directly downscaled, not using the regional climate models, and they're listed here. They're at about a 28 kilometer resolution, or 0.25 degrees. That they're bias adjusted using the statistical approach for many of the GCMs, and these are CMIP6 products there. One disadvantage here is they don't have the snowpack, and some of these nonlinear processes like snow are not as well represented with the statistically downscaled products as they are with the dynamically downscaled products. So if your region maybe is dependent on snow melts or something like that, then you would probably want to work with the regional climate models. I think I'm running sort of low on time here, but Majid is going to show these pictures, but this is using EuroCORDEX for the Nitra Basin, and we just have some the evolution of the data showing some of the uncertainties with the EuroCORDEX, the Q50 being the ensemble median, And then we have the 10th and 90th percentiles of the data, same for precipitation. Here we see temperature increasing, of course, as we expect, a slight increase in precipitation, but not much, and some models showing a decrease. And then if we look at a measure like drought, this is SPEI, which is standardized precipitation evapotranspiration index. And we see that this index is decreasing, which means that drought is decreasing. The index measures sort of the precipitation as well as the sort of thirst of the atmosphere, which is measured by temperature. And you can see that drought tends to increase in the future by this decreasing trend line here. But in a worst case scenario, you might see something like almost a permanent drought in some of these regions, whereas in a best case scenario, not much change at all. With that, just want to advertise a few things here. One is the CLIMAAX community in practice. You're all here, so you don't need to join that. I guess you're already part of that. But we have a lot of these workflows in the CLIMAAX project. So our handbook and framework are in there. And then really would love you to take our survey that we have with CLIMAAX. But I don't want to spend more time on that, and I want to pass the floor back to Anna. Thank you.
Thanks very much, Jeremy. That was really interesting and a wealth of information. It'd be interesting to hear from our participants. Maybe you could start writing in the chat if you have some reactions, if you have some questions, and we can come back after Andrea and Majid's talk. But I want to emphasize Jeremy's point about the survey. A key issue here is to understand what your questions are and like what is the application that you are working on, and based on that, then it's possible to kind of work back and navigate this enormous amount of information that the climate science community is producing. So navigating that is a challenge. And what we try and do with CLIMAAX is, on the one hand, give access, easy access, and the other to all the data. And the other is to try and promote a best practice approach. And so, you know, as Jeremy said, one model is not telling you what's going to happen. I would say it's not a forecast or anything like that. You've got to understand how each contribution of the models and the different scenarios helps us understand how the climate may evolve in the future. And so here we are looking now at biases and uncertainties in these projections. And so based on that, you hopefully, thanks to the workflow that's been developed, you'll have a kind of basis with which to start thinking about how to select scenarios. And clearly, it's not a simple process. We have this wonderful project to work together to exactly make that process of selection come out, thanks to the collaboration we have here. So now let's go over to our next speakers. So first, we'll hear from Majid Niatskar. He is a researcher also in Jeremy's division, the Risk Assessment and Adaptation Strategies division, and he's working on a whole series of projects around understanding climate risk and adaptation and building resilience. He is a civil engineer by background. He holds a PhD in civil engineering and water resources. He comes from Iran. He was at the Shiraz University, and then he also worked at the University of Milan and the University of Bolzano. And then we'll hear from Andrea Rivosecchi. He's a junior scientist at another division in the Euro-Mediterranean Center on Climate Change. It's a division that looks at the impacts on agriculture, forests, and ecosystem services. And he's also a PhD student at the University of Reading. And he's working on climate change modeling, particularly on its representation of extreme weather events and connecting that to climate risk adaptation strategies. So over to Majid first. Yes, I get the order right. Majid. Confused myself. Sorry.
Thank you, Anna. Hello, everyone. Let me share my screen. Do you have my screen?
Yes.
Yes, thank you. Hello again, everyone, and welcome to the presentation of the new workflow in CLIMAAX project. So what I'm going to present to you is to to talk about more about the uncertainty, building up on the informative presentation presented just by Jeremy. So I would like to start how and where are we? We have a lot of information available, but which scenario, which climate projection is suitable for us? This is the key question of probably you that today you join us. I would like to start about what is the importance of the uncertainty and why we should care. So I prepared this slide as like a hypothetical chat between a stakeholder and a researcher in CLIMAAX. So probably you are interested to know how much precipitation your region will get in future, and the question is from you, and the response is clear that we have climate models available that you can use. But you may wonder, is it 100% certain the results, the information that climate models are providing for you? The answer is indeed no. Just because climate models provide you future projection like weather forecasts, they have uncertainty, as you already seen in a lot of pictures that Jeremy just shared. But your hesitation is which one to actually select for your own region regarding your perspective and application and purposes. So this is why we develop the CLIMAAX uncertainty and bias workflow to help you. And today we are going to actually hear from you and share with you the very initiative version of the CLIMAAX uncertainty workflow, to hear from you your feedback, how to proceed, is it useful for you? Regarding uncertainty, so what is uncertainty? Let me tell you what uncertainty is not. Uncertainty is not knowing anything. Actually, if you look at the sign here on the side of the road, it gives you different or a variety of possibilities that you may encounter along the road in your future. But we are not 100% sure which will happen, but we give you a range of possibilities. Actually, the climate model, each models ended up with a unique future projection for you. But which one should you use? This is actually the good question that this workflow is going to help you address it. So why uncertainty? Actually, why these climate models ended up and resulted into different future projection and estimation? I would like to highlight different kind of origins inside the climate models that can work together and ended up having different values, different prediction for future. Among them, I would like to highlight natural variability, the phenomenon, the natural phenomenon that governs and can change the situation, and also the model itself, the model differences. Each model has some assumption behind it, and also based on what we do today, how we reduce the gas emission, we can change our future. So our future is also depends and rely on our actions today. So these factors can play in a complex way together in order to change our future. This is why our climate models are not 100% sure about what is going on in future. But why uncertainty is very important. So if you rely on just one climate model results, on one climate projection, can you expect to see the extreme events that may happen in future? Just very recently in Spain, we have seen extreme events in different regions. Barcelona, there was a drought. Valencia, there was a flood, which is like extreme climate related extreme events that may happen to any region. But these climate models can give us some perspective of what we should do to prepare and plan for it. So I would like to show you the results of that Jeremy's mentioned. So this is actually precipitation and temperature of different climate models, actually 62 different climate projections that we consider for Nitra Basin in Slovakia. So as you can see, as we are going forward through the time, we will have different, a wider range for temperature, and also a slight increase of the median of the ensemble models. As you can see, the worst and the base cases, the climate projections are too wide and far from one another, and can give you extreme events in both sides. I would like to tell you how we should plan for this kind of uncertainty that is like embedded in our climate projection. One of the key idea that you can also already gotten from the Jeremy's presentation is to use not only one model, but also an ensemble, a selection of different models, different climate projection, to actually consider an average to be more reliable. And another thing is to use the different ranges actually, which may happen in future. So I would like to suggest that not run your model just only based on one future possibility, one future projection, but from different ones, and provide a variety of different possibility and climate projection in future. This picture is somehow repeated in our presentations, but actually this is to highlight that there is actually global and local scale of this range of the uncertainty and different variety as we are marching through the time. I would like to present here to you the beta version, actually, as my last slide, the beta version of the CLIMAAX uncertainty and the bias here, and we will probably show it today much more and discuss it more. But regarding the uncertainty for any region that you are interested in, we develop a pop-up figure that like this, that shows you on the left side the bias, which is, for example, bias of the precipitation and the temperature, which Andrea will go to that and present it more comprehensively for you. But regarding the uncertainty, as you can see here, we have different models. Actually here 7 models, 7 climate models for this region, for Nitra. And then we show you the range of the possibility, and also this model that you selected based on the bias. So at one shot and on one figure, you can see the uncertainty of the model and the bias of the model, which can help you have a better perspective of the climate projection when you are going to select them. I would like to end my presentation now and give the floor to Andrea to talk more about the bias. Thank you.
Thank you very much, Majid. Over to Andrea. You're going to share your slides, right?
Yes. Give me a second.
And just to say, feel free to put any questions of clarification in the chat, and we can come back after Andrea's presentation.
Okay, good morning, everyone. I'm Andrea, and today I'm going to present you the bias assessment that we perform inside CLIMAAX, and the tool that we developed to show you how you can measure bias and how you can use it to better select your climate model for the workflows that you might want to use in CLIMAAX. So just to give you an outline of my presentation, I'm going to start giving you a bit of a context of what bias is and what we mean by bias in a climate model. And then I'm going to quickly talk about why do we care about it and why it is important, even when we look at the future. So bias is something that we look for in the past, but it's got very big impact in the future as well. And finally, I'm going to present you the beta version of the tool that we developed, and so how we want to navigate bias in CLIMAAX. And this will lead on to the discussion and the feedback from you on the tool and ways that we can improve it, or what you want to be added to it. So just to start off very quickly, I thought it would be important to set the scene and say what bias is. So as Jeremy and Majid said before, climate models offer a good representation of the climate system, but again, they're not perfect. However, there are several ways in which we can process the data that come out of a climate model to make them more robust and more similar to the observation. In fact, this accuracy of a climate model output varies with time, space, and the type of model. As Jeremy and Majid said, in fact, if you consider a year-by-year basis, you cannot expect a climate model to perform exactly as the observations. But if you average over a long enough number of years, then the performance of your model will improve. This applies also to space. So if you average over a larger region, you can expect the climate model to give you better and more robust results than if you just consider a point in space. Finally, the choice of the model also affects the bias, because some models will perform better than others at a given location or at a given time. And this model choice is what we are trying to address in this tool. And this is because in many of the workflows that are present in CLIMAAX, you'll be having to take this choice and to select the climate model that you think would be best for your region. So why is bias important? So first of all, climate model data, as you might know, is the foundation of a risk assessment. So if you don't have an accurate representation of your hazard, you will probably end up with inaccurate results for your risk assessment overall. And then a second very important point that is a bit more technical, but I think it's worth thinking about, is that if you have a small bias in the mean of any climate variable, so if you have a small difference in the representation of the mean temperature, for example, you can end up having a big difference between the model and the observations when you look at the extremes. And since extremes are often what we use in these workflows in CLIMAAX, since they are the most hazardous and they are what we're concerned about, it's important to look at the mean error of the model to have then a lower chance that the extremes are also misrepresented. Coming to the tool and to what it looks right now, I bear with me for a second with a bit of maths, but it's very simple and it's just to make you understand a bit better what we're doing here. So currently we calculate the bias for temperature and for precipitation that are usually the most common variables in the workflows. And what we do is we simply take a 30-year average of the model data and subtract it for the 30-year average of the observations. So for temperature, it's a really easy calculation, and it just gives you an absolute value in degrees of what is the difference for any given point inside a region between the model and the observations. For the precipitation, it is basically the same, but we express this bias as a percentage, and we refer it back to the observations to give it a bit more context. Because, for example, if you think about a very wet region, a small percentage change in precipitation could be quite significant. But if you think about a dry region, then this might be not as important. So this is why we express the temperature and the precipitation bias using two different metrics. And this assessment is done for every point inside a given region. And the tool is set to work at NUTS2 level, so at the regional level inside Europe. And so then we average the result of all these operations inside one region. So this is what the output then looks like. This is just an example for one random region in France. And so as you can see, you have the colored dots that each represent a Eurocortex model. And just to get a bit familiar with the nomenclature, for any Eurocortex model, you have first the name of the global climate model, and then you'll have the little underscore. And after that, you have the regional climate model. So as you can see here, you have for the same global climate model, different regional climate models. And this already introduces some differences between them. So after that, you can see down here, this black square that represents the observations. And so as you can see, the black square plots at the 0, 0 in the axis, because of course, that's what we aim for. So the observations have 0 bias in both precipitation and temperature. And then to guide you better in interpreting the plot, we also added these blue and red lines. So just to make this clearer, if you look at the red line, there are these two models in this case that do a pretty good job at representing temperature, since everything that plots close to this red line will have almost 0 temperature bias. And then moving to the left of the red line, you have the models that predict a colder climate than what we observe. And moving to the right, you have the models that predict a warmer climate than we think it is. The same goes with the blue line, and the blue line does this for precipitation. So as you can see, this model here is one of the best at representing precipitation in this region, since it plots quite close to the blue line. And then anything that plots above the blue line tends to be wetter than the observations. And then anything that plots below the blue line tends to be drier than the observations. And so to guide your choice, the best models will be those that plot as close as possible to the black square here, that is the observations, or to the lines. Because, for example, you might be interested in a workflow that mainly deals with precipitation and not as much with temperature. So you might want to consider this model as well, even though it doesn't have as strong representation of temperature. So moving on, I can give you a quick look through the tool and how it looks right now. So I'm just gonna put it up. Can you still see my screen?
Yes, you've taken down the presentation mode. We still see your slides.
Okay. Do you see the... Okay. Just give me 1 second.
I think you need to stop sharing and then share your Python workflow.
Okay, great. Thank you. I'll do that. Okay. Can you see it now?
Yes.
Yes.
Okay, so this is the land page of the tool and how it looks right now. So as you can see, you have Europe divided into the NUTS2 regions that I was talking about, and you can navigate this map and zoom in and zoom out. And then on the right-hand side, you have the possibility of selecting different forms of bias. So for the moment, we only have the bias on the annual data, but we plan to also implement seasonal bias, because we think it would be important to have a better representation of seasonality. So for example, for the summer and the winter. So if you click on the layer, then the data will magically appear on the map. And if you zoom in, you can see how for all of these regions, you have one data point. And if you click on any given region, this opens up the plot that I showed you before. And you can, the way the plot works is exactly the same as before. So you have the 2 lines of 0 bias, and you have your black square for observation. And the plot is also interactive, so you can use these little tools to navigate it better. So for example, if you're interested in the difference between this model and the observations, you can draw a little square, and this will zoom in, and you can see better the scale of the difference. And then you can always go back to your home plot to see the overall picture. And again, this is only a beta version, and the final version will have also the uncertainty plot next to it, as Majid was presenting. And also, this is just a limited collection of all the Eurocortex models available. So this was just to give you an idea of how it might look later on. So thank you for your attention, and I hope you...
Thanks, Andrea. That was really, really good. Really fantastic to see this live. Maybe just keep it open for now, and we can talk about it directly. I think this series of presentations has been very useful in first telling where all these models come from, what the origin of the data sets are that we have in the workflows of CLIMAAX, and then putting onto the table, shall we say, all the considerations of how we choose which information in the context of the work that each one of you is doing. And it's very difficult to navigate and give also one guidance. Like, it's very hard from a climate science perspective to say, well, you should do this, you should select these models, and you should move forward with that information. So I think this workflow is very nice because it gives you the choice directly to go and navigate yourself and decide how to start selecting the information. And I think it's really important at this stage to remember a few kind of the best practices, ideas that came up in earlier presentations. So we see one or two models that are performing well. But again, remember, it's important to see many simulations of these models and not just rely on one simulation. And then clearly, when you start finding these sub-selection, you can identify 1, 2, maybe 3 models that you want to concentrate on. It's really important to look how these models are producing the historical climate conditions in your region, and you can check how they represent extremes in your region, and then start thinking about the information they provide in the future. So, but probably in the context of applications of this information, it will be important to be able to explain to your audience how you derive the information in terms of future risk assessment. Anyway, the point here is to hear from you, like what your feedback is, what do you think in general on this topic? What's your experience in trying to assess changes in climate hazards in the future? And maybe your reaction to this proposed workflow. So it's really going to be developed also listening to your views and your suggestions. So the floor is open, and obviously you can put a question in the chat, but you're really welcome to raise your hand and just react and give your thoughts. It'd be really interesting to hear what you're working on, which region you're working in.
Anna, maybe while we wait for someone to activate their microphone, I wanted to emphasize one thing that's really related to this workflow. And I think, when assessing model bias, it's really important to, I think, understand, or at least this is the philosophy that I use, is that if a model can't simulate past climate well in a particular area, we shouldn't expect it to be able to simulate future climate. So this particular workflow can help narrow down those models that are doing a very nice job of simulating the climate in a particular region, and then that model then can be used for the climate risk assessment, because we can expect the regions to download all 133 combinations of these models. But maybe they can narrow it down, as you said, just to a few models, maybe 5, 10 models, or and then do the risk assessment based on that subset of models for different scenarios.
Yes, I think that's a very good point. It'll depend on the characteristics of your region, the geographical characteristics and the climatic conditions, and how these models are representing those processes.
And a lot of these bias adjustment procedures mask some of the issues with the model. So you bias correct or bias adjust the model, and it may look good for the region because of the adjustment, but in reality, it's not representing the processes very well. So that this particular workflow would be very good, I think, for identifying those models, and then you can even use the bias adjusted product afterwards, but just to narrow it down to the subset.
Yes.
But as Anna said, we really want to hear from you. We want to get feedback
Exactly.
on these two workflows that are being developed for the toolbox. So please open up your microphones, turn on your cameras, or chat if you're shy.
Yeah. One thing I was thinking when Andrea was presenting, you see the models that may be hotter or colder or wetter or drier. It's also really interesting to look at both outcomes and think in the future. It could be that the models that are producing the wetter outcome may be the outcome that you will encounter in the future. So perhaps in planning risk management strategies, it's a good idea to understand both behaviors, shall we say, in these models. Would anyone like to come in and break the ice?
I think I see Darren has opened his microphone.
Yeah, thanks. I'm actually coming to CLIMAAX from working in South Australia, and so I'm a fair way away, but doing a fair bit of work in trying to turn the Australian CMIP6 based simulations into downscale simulations into useful insight. So really like what you guys are doing, and yeah, so I mean, you touched on that, Anna. I've been wondering that myself, whether there's a use, whether applying the different model sensitivities as a way of examining, the different responses in the system might actually be a good way to look at things myself. So, yeah, you've touched on something I've been thinking a little bit about myself. How do those, for example, how do those different pathways for the different models, what do they look like if you start grouping those by model sensitivity?
Yeah, absolutely. So I guess here we look at the performance historically, and then you could consider the future scenarios, selecting maybe a low and a high-end emission scenario and see how those models then behave going forwards. And some may have this sort of wetter characteristic, others may be drier. I think it's all very important information. And if you have an ensemble, so a whole set of these simulations, you can look at the spread. So you have an idea of how uncertain this information is in the future. And you can have a medium projection, but also you could look at the worst case, so the higher end of the spread. So these dimensions, I guess, of future climate could be very useful to look at future risk and present a very clear picture also to your audience. It's interesting, you're coming from Australia, so welcome. It's nice that you're here as well.
Yeah, thank you. I mean, I came across the CLIMAAX work last year. We're in the process. There's a lot of at various both national, state, and local government level. There's a lot of risk analysis and risk assessment work going on, and we're still sort of trying to formulate a robust framework and robust analysis processes that inform those different levels of activity. And yeah, I think that particularly the tools that you guys have set up and their accessibility on GitHub and that sort of thing, there's some really great stuff in there. So we're really interested in seeing whether I can adapt that to what we're doing here.
Yeah, that's lovely, because it's really the whole spirit of the community of practice. So I'm sure many on the call are actually participating directly in the CLIMAAX project, the cascading funds, but then we really open up this discussion to share with the broader community and hear also about what you're doing. So it's great. I'm glad this is working out.
And I think, Darren, you mentioned one thing as well, and I think with Majid's, the workflow that Majid's working on is sort of this clustering analysis. So one can also select some of the models by seeing where maybe based on their sensitivity. So hotter, drier models might be clustered in one area, drier, wetter models in another, and so on. And then one could do their selection, sub-selection based on the bias and as well as their sensitivity there. And that's one area I think we want to focus on as well.
Yeah, I see there are two comments in the chat. Biena, would you like to speak, or I'm happy to read your question? Feel free to unmute if you'd like to come in.
Thank you, everyone. Thanks, Anna. I think the great presentations and very informative. I am also not from the user community as such, but I have used projections for some time. So it was quite informative to listen to the presentations. And it's a great tool in communicating bias from the chain of uncertainty metrics. And I was wondering, it would be useful to mention the time period for which the bias is calculated in the plot, or even better, I'm not sure how it works. One of the suggestions would be to add an option to calculate each 20-year period, as Jeremy mentioned in his talk, to compare. And I also have a question, maybe for Majid or Andrea. Which regions or which region within Europe you find the biggest spread in hottest temperature and precipitation?
Thank you. That was great to hear from you. Andrea, maybe would you like to react on the suggestions? Because I thought there were some very good suggestions on how the functionality might improve.
Yes. That is actually a very good suggestion. So for the moment, bias is only calculated for 1970 to 2000. So that's the 30-year period that was chosen for this preliminary version, but definitely it will be good for later versions and the definitive version of the tool to have the possibility to calculate it even in different periods. And regarding the biggest spread, I'm actually not sure. I haven't checked all of the regions, but I would probably think it's somewhere with the most extreme climate, probably. So I would think maybe the far north of Europe, but I'm not sure. I haven't had an exact look at all of the data.
Thank you, Andrea.
Anna, you're muted.
Yeah, sorry, I muted myself. Andrea, I was going to ask you, so you're planning to also have the possibility to look at this bias correction for future time slices, right? So you're looking to the future.
No, sorry. What I meant is maybe a different period in the historical still. So because there could be the possibility that if you take a different, let's say, 10-year window, you might end up with slightly different results. So it's always in the historical time. So it's always compared to observations. But yeah, we might adjust, and instead of 1970 to 2000, we could consider 1980 to 2010. So having an extra 10 years there.
Yeah, and I guess that also will be regionally dependent on how the information changes. Yeah. So I guess the point here is really for users of this application to really explore as much as possible all the different combinations. And yeah, that's very useful. Eric, I see you in the chat. It's nice to hear from you as well. You're from Sweden and you're a climate modeler. You've been working in climate services and adaptation. If you feel like it, no pressure. It's nice to hear your reactions and what you think. Anyone else is welcome, of course, to raise their hand.
Yes, hello. Can you hear and see me now?
Hi, Eric.
Hello. Yes, so I think this workflow can be very useful. It's good that it's made for all these different regions in Europe, because I think the result will of course differ for different parts of Europe. So, but I don't have any more like specific comments on it now. I think they will come when we start using the tool and look at the different results for different models. So
yeah.
So, but nice work and a good help, I think, in the work.
Thanks for the feedback. And there's a comment or a question from Tamer, who's working in Turkey. Would you like to come in, Tamer? Feel free. So you're asking how this workflow could analyze in more depth the uncertainties. Maybe this could be something that Majid could respond to on the future development of the workflow.
So if I understand...
Sorry, I open my microphone. In Turkey, as I said, our State Department provides some data or regional projections in our regions. Şanlıurfa in the southeastern of Turkey. We can use these projections. Those projections are based on RCP 4.5 and RCP 8.5. So we will use we plan to use these projection in the second deliverables of also in the CLIMAAX analysis. But can we analyze these data sets, whether those data sets are useful for us? I mean, the uncertainty of these data sets can be analyzed with this workflow.
Okay.
So only can use the, for example, Eurocordex domains data sets, or also another questions in our region in Şanlıurfa is our region is out of Eurocordex. For some parameters, we used Mediterranean Cordex data sets, especially for the agricultural drought analysis. So these workflows covers also the other cordex, Mediterranean Cordex, for example.
Yeah, I think one of the issues with Turkey is that it sort of falls in between some of these Cordex domains. But yeah, I think the Mediterranean domain extends to cover most of Turkey at least. And also there's I think it's the Central Asia Cordex domain that is potentially useful. But these workflows are designed to be, the code is open, so one can download the code and modify it, and you could modify the code to use any of the Cordex experiments. Some of the issues with I guess they should be adaptable, but the Eurocordex, for example, is on a 12.5 kilometer grid, whereas I think the Central Asia and the Mediterranean, I'm not sure. I think there might be on 25 kilometer grids, but I think the workflows will be designed that you can put in any different Cordex data set into them, and perhaps even global models.
Yeah, so thanks. You're just reminding the whole spirit of the way the workflows are developed. So it's all open source, and you're welcome to use them in your own application. So take them down and work on them on your own areas. Majid, did you have something you were going to come in as well on looking at uncertainties?
Yes, I would like to say that what actually this workflow is targeting is to make your life easier, because if you want to work on the climate projection, you should have first download a lot of information, gigabyte, terabyte of information, and then start coding and working on them and calculate bias and uncertainty as well. So actually these this workflow is to address which climate projection is making your region the future projection. So it's useful for you, it's suitable for your application, and this will like give you some hands-on practice in your endeavor. So the idea of uploading your data inside the code, because the code will be open source, is somehow like not in line actually with what the workflow, as far as I think, is not in line with it. So you can already use this information to select the models that you want from this Eurocordex data. I don't think that we will cover other Cordex information, at least at this moment, because as you can see in the map, there are a lot of regions already inside Euro that we are working on. So, but it's nice that you can also modify the code and tailor it to your specific needs.
Okay, thank you for this.
Thank you for that, Majid. And there's a question from Eric. He's asking, maybe Andrea, you could answer this question. How is there some sort of selection for the models that we're looking at here? Or will this be amplified basically, as this is a proof of concept, a beta version? Are you planning on extending the combinations that will be available to select?
Yes, so these models were just selected randomly out of the whole pool available, and we're definitely thinking about expanding it, and actually also on how to expand them, because as Jeremy was saying, there are a lot of combinations, so it might not be worth showing all of them, and especially those that show a very large bias. So we will definitely expand the selection, but maybe doing it with a bit of a filtering pre-applied, so you don't end up with plots that are crammed with dots that you cannot really then interpret. But yeah, the selection will definitely be expanded.
Thanks.
I think that, sorry, if I just add on to what Andrea is saying, you know, in the two workflows, only precipitation and temperature have been shown, but the plans are to expand it into using sort of hazard variables, maybe extreme temperatures or precipitation, to since that's how most of the risk assessments are being done, with the more extreme variables. So to analyze how the models are representing the extremes as well. But this is just the initial product, and the idea is to extend it to other variables that might be important to each of you here.
Okay, so thank you. I mean, I think now we're going to have to wrap up this discussion. We have just a few more things to cover in this meeting, and I'm about to hand over to Fulvio, who's just writing in the chat. He's saying basically that, you know, we keep hearing your views, and now we can carry on by email. If you have more insights or more questions and ideas, just write to the email cop@climax.eu. I really want to thank Andrea, Majid, and Jeremy for their presentations and for the discussion. Thank you for your participation in this discussion. Also, everybody in the audience. So now back to Fulvio. He's going to try and explore with you how we could keep improving this journey with the community of practice. And maybe one thing we can bear in mind is another meeting in the near future when we can see the outcome of this discussion and the further development of this workflow, for example. It'd be really good to come back together and see how this is proceeding. Thanks, and over to you, Fulvio.
Thank you very much, Anna, and thank you also to Jeremy, Majid, and Andrea for this nice presentation of the workflow under development, but also to you for the discussion. So as anticipated by Anna, now we'd love to hear your input about the COP journey so far. Maybe many of you already participated in some of our meetings, but in any case, we want to hear your feedback and input also to plan for future activities, because your feedback could help reflect on the past, but also shape the future of this community of practice. So I'm going to ask you so I'm going to ask you to participate in this very quick poll. You can go directly to www.menti.com and enter the code that you can see displayed in the slide, or you can also use your mobile phone to scan the QR code and join this poll. So I'm going to wait for a minute or so to leave you the time to join this poll. And just as you know, we want to hear from you because it's really important. We want to tailor the activities for the future and also hear from you to improve what we are doing in this CLIMAAX community of practice. So I hope everyone has already joined and I could try to start the Menti. So now we want to reflect on the past, and we would like you to rate some of the aspects that characterize the COP so far. As you know, we delved into different topics addressing the social but also the technical components of climate risk assessments. We delved into different aspects and different outputs from the COP. First of all, we delve into the framework and the toolbox of CLIMAAX, addressing it through presentations from our partners, but also from the regions that really applied on the ground the framework and toolbox. But we also hear about how to engage meaningfully stakeholders and citizens. Even here with panel discussion with practitioners sharing their experiences. This is kind of the format we use so far. So blending an introduction to key resources and guidance and tools with practical approaches on the ground by practitioners. And we held usually these meetings monthly, usually the fourth Thursday of the month. So we have some regularity. And we use emails to communicate with you. You can join the community of practice through our website, but also through our LinkedIn group. And we try to blend this kind of level of interaction between Q&A, panel discussion, and in front of presentation. So I can see there are already a few inputs for us, and I can see that the topic were highly relevant, that is really helpful for us, and also that the level of shared resources was good enough. So thank you for your input so far, and I'm going to move as I can see the responses have stabilized. So here there is another question for you on which activities will be most valuable for your future engagement. We selected a few options that we are willing to implement in the community of practice. We have peer exchange sessions, so moments of discussion between peers, sharing their experiences, challenges, and so on, but also hands-on tool demonstrations or workflow session. And today we had a similar hands-on tool demonstration with this beta version. But we also want to hear if you are interested in facilitated thematic discussion, or also if you would prefer having also asynchronous engagement formats, such as forums with thematic threads and these kind of things like resource sharing repositories. Or also if you are more interested in more active engagement with working groups or task forces, for example, for shared publications, funding proposals, and this kind of work. I'm waiting a little bit more to understand if responses have stabilized. In the meantime, I can see that, of course, maybe there is a bias in this in this event about bias and uncertainties because it's a more technical session, but I can see that hands-on tool demonstration and workflow sessions are really appreciated as a format for engagement, followed by facilitated thematic discussion. Where little interest is in working groups and task forces. I can see responses have stabilized, so I'm going directly to the next one. And this is just your opportunity to provide some other feedback or input to us in a more free and open way. So we have open responses format, so about what would make the COP more meaningful and engaging for you. So we discussed about the format, the contents, but maybe there is some other feedback that you could provide to us. So I'm leaving you the time to reflect about it and share your thoughts. Don't be shy. We are here to listen to your input and feedback as we are really trying to address your priorities, needs, interest. So we have a first response, which is sessions on specific risks would be really useful to understand the main formats of these kind of sessions. So more about workflow demonstrations or also practical experiences on the ground on the assessment and adaptation about specific risks, having the chance to connect with colleagues interested in making my climate risk assessment into their region. There is some uncertainty here about what is going on, but also their input going through ways to make decision of climate risk assessment, which models to use, which RCP to use. Okay, that's really great to hear your feedback. And also, could we have a smaller session for a number of neighboring countries with similar risks? So the fact of having geographic similarity, and this is really important to us. Somehow it will be easier to engage in the COP if we have more information of the contents beforehand. That's a great, sorry, I was trying to scroll it down, but that's really good feedback for us. We are trying to plan in advance, but even this monthly meeting is quite difficult to have more contents beforehand. We will try to make our best and available to operate tools to get more hands-on practices, live workflows demonstrations, ways to engage with other regions, and technical example. This is really great. Thank you for your input so far. So as we are running up of time and we want to wrap up today's sessions, I want to extend a big thank you to our speakers and especially to our moderator, Anna, for being with us today. And before we close, mark your calendar for our next event because we are planning on May 22nd an event that is focusing on funding opportunities and financial instruments for supporting climate risk assessment and climate resilience in regions. And this event will be a joint session with our sister project P2R, Pathway to Resilience, and other mission adaptation projects to introduce key guidance resources and that will support you navigating the adaptation finance and funding opportunities, but also offer practical guidance for practitioners seeking support for climate adaptation. And moreover, in this event, we will also announce upcoming funding opportunities for regions. So stay tuned for more details that will be shared quite soon. And finally, before we close, a final message on how to stay engaged with the community of practice. If you'd like to keep receiving updates or participate in future sessions or receiving the materials and continue the conversation, there are multiple ways you can get involved. First of all, you can join the COP by joining the LinkedIn group. We will put the link in the chat, hopefully some of my colleagues. And you can also take part in our ongoing surveys that were disseminated by Jeremy as well. to help us better understand the state of climate risk assessment in Europe and also on investment needs and challenges in climate services. This input will help us to further refine the digital handbook, but also to plan the future activities for the community of practice. And you can also subscribe to the CLIMAAX community of practice using our website. So there is under the participate section of the website, the community of practice, and you can just click the register button. You can find it at the page and include your email to receive updates, invitations, and access to session materials. Also there you will find the recordings of previous events, so you can catch up with the sessions that I just mentioned about the toolbox workflow, but also stakeholder engagement and climate risk communication. And finally, another opportunity to engage with us, sorry for that, is represented by the technical support drop-in sessions that are weekly organized by our partners from ECMWF, and you can find the calendar and meeting links in the chat. I'll leave you some time to copy these links. And as usual, you can write to us using our email address that is cop@climax.eu for any questions, feedback, or just if you want to receive the materials from previous events.